we're going to sketch a couple of parametric equations by hand and see how to do that. So when you use to graph functions, you would make like a table, and you would put like x on one side and y on the other. And then your input value would be your x. So you'd list your x's there and then get your y values. Well, in a parametric equation, what we need to input is our t and the parameter t. And so we're going to choose some numbers for t, and then we're going to find what x and y are based on that value of t. So we'll just choose some values of t. In a real-world situation, I'm not used to using negatives to represent time, but we can do that here. So if we let t be -2, then what we're going to do is we're going to plug in -2 into t in the x equation, and that's going to give us -2 squared minus 4, so that's going to be 0. And then we'll plug it into the y equation, and we'll get -1. And then for -1, plug that in there, I think we'll get -3 for x and -1/2 for y. And so what I'm doing is I'm taking this number for t and I'm plugging it into t here and here in the two equations. So 0 squared minus 4, and then 0 divided by 2. And then 1 squared minus 4, and 1 divided by 2. And 2 squared minus 4 would be 0, and 2 over 2. And 3 squared minus 4, let's see, that'll be 5, and 3 over 2. Okay? I want to plot these points, so we'll see what it looks like. So we've got 0, -1, and that happens when t equals -2. We have -3 and -1/2. We have we have -4, 0. That happens when t is 0. And -3, 1/2, 0, 1, and 5, and 1.5. So our graph looks something like this. And this is where t is -1, this is where t is 0, t is 1, t is 2, and t is 3. Not that you would have to put those on the graph every time, but it just gives you an idea of where the graph comes from each value of t. So that looks like just a parabola, a sideways parabola. So what if we wanted to change our parametric into a rectangular equation, or into an equation with just x and y? Well, what we're going to need to do is get rid of the t, right? The t is what's causing it to be parametric. So what if we could solve one of them for t and then plug that into the other equation, and then we might have an equation with just x and y in it. So if we look at our two equations, which one is going to be the easiest to solve for? Should we solve for t in the x equation or solve for t in the y equation? Hopefully you agree with me that it might be easier to solve for t in the y equation. So that's going to be t equals 2y. Okay, so I just took that equation right there and solved it for t. So if t equals 2y, then in the other equation, where it says t squared minus 4, I can replace t with 2y, and minus 4. Okay, and so this will be x plus 4 equals 4y squared. And this is similar to how we were doing our parabolas earlier. If we divide by 4, we can put it in standard form like we're used to. And if we do that, from here we know that the vertex is at -4, 0. And we know that the lattice rectum is 1/4. And we can find the focus too. And so anyway, we see the vertex there, and the lattice rectum is very, very small. It's right there next to the vertex where the focus is. So the lattice rectum is very small. Okay, so let's try another one. Okay, so this one So I've already made my table, so I want to graph this thing by hand. I'm going to start with -3 to 3 for the t values. So let's see, I hope I don't make a mistake. See, that'll be 9/5. Then plug in -2, be 4/5, and -1, and 0. If I plug in 1 for t, and remember, all I'm doing is I'm taking these values of t and I'm plugging them in for t over here and getting the x and the y. So it'll be -2 and 1/5 for the y, and -4 and 4/5, and -6 and 9/5. And if I graph these over here, I get, oops, see, that's 5, 6. I get 6, let's see, 9/5 is almost 2. And then at 4, we've got 4/5. And at 2, we've got 1/5. And then it's symmetric on the other side. So something like this. Okay, again, looks like a parabola. So if we want to try to figure out the rectangular equation for this one, I would probably solve for t in that first equation. So t is going to be x over -2. So y is going to be x divided by -2 squared over 5. So what I'm doing is I have found t, and so I've plugged t into the equation, into the other equation. Okay, and so we'll simplify that. So you get y equals, actually let's go ahead and do 5y equals x squared over 4. And let's see, that'll be 20y equals x squared. So again, this is a parabola, and this one opens vertically. The other one, since it was y squared, opened horizontally. So the vertex is going to be 0, 0. And on this one, the lattice rectum is going to be 20. So you can see, and the focus for this one, remember 20 is equal to 4p, so p would have to be 5. So here's our focus up here. And if the lattice rectum is 20, we're going to go out 10 on each side. And that's how wide your parabola is going to be through the focus. So we've got a parametric equation and a rectangular equation that both graph the same parabola. They're just doing it in a different way. All right, let's do one more. Okay, and again, we'll start out with plugging in -3 through 3 for t. So let's see, -3, that will be, I think, -9, and then -4. So I'm taking this number -3 and plugging it in both places to find x and y. And this one's going to, the x we can see is going to be linear. So as t increases by 1, our value for x is going to increase by 2, because the slope there is 2. So let's go ahead and fill that in. That'll be 3, oops, -1, 1, and 3. Okay, and then the y's, let's see, if I plug in a -1, I'm going to get -12 here. Well, if I plug in 0, notice that you can't divide 12 by 0. So let's put undefined right here. Okay, and then 12 divided by 1, 12 divided by 2, and 12 divided by 3. Okay. So let's see. So -9, -4. -7, -6. So down a little bit further, so I can be exact here. And then -5, -12. It's going to be way down there. Okay, so something weird's happening at t equals 0. We'll leave that alone. And then -1, 12. It's going to be way up there. 1, 6, it's going to be somewhere in here, and then 3, 4, maybe here. So this was kind of confusing to me a little bit, so I graphed it on my calculator. See, I'm not sure if I can get, yeah. Okay, so let me go to my calculator. So I graphed it here on my calculator. So there's the equation. And when I did, I got this graph here. And I was like, oh, wow, there's an asymptote there at x equals -3. So at x equals -3, there's an asymptote. And which I guess, now that I think about it, is what we expect when we divide by 0. So we've got this asymptote there at -3, and then we've got this kind of graph, a rational type function going through there with an asymptote at -3. So that's the basic idea of how to graph parametric equations by hand, and also how to change them. Oh, I didn't do the change into the rectangular on this one. Let's try that one. So for this, let's see. This one looks pretty easy to solve for t. Actually, they both look not too bad. But if I solve this one for t, I'm going to get t equals 12 over y. So if I take that and I plug it into the other equation for t, 12 over y minus 3, now I have an equation that no longer has t in it, but has x and y in it. So let's see. I'll go ahead and do x plus 3 equals 24y. That's not a very nice format, so let's bring the y over. So we would multiply y times x plus 3 equals 24. And so what we've got is this xy plus 3y equals 24. So, oh, now I got maybe a better way to write that would be y equals 24 divided by x plus 3. That's what I'm looking for, because that shows me that there should be a vertical asymptote at x equals -3. So good luck with graphing parametric equations.